Okay, we are doing the definite integral today, 5.3. So pretty much everyone answered the question on the WSQ correctly. The question was, how do you go from a Riemann sum into a definite integral? The answer is make the interval as small as possible. So either make it really, really small, so then you have infinitely, or you can say you have infinitely many intervals. That's the only way to turn from Riemann sum, which is all small rectangles, into a smooth curve. All right, so let's look at our definite integral. First, we got to start from our Riemann sum. So if you recall, the Riemann sum is basically adding up all the infinitely many little areas of the rectangles. The rectangles are base times height, so the height of the rectangle is f of, let's kind of draw it up here. So we have, let's say from here all the way to here, so then we're just drawing all these little rectangles, right? So let's say that we start from here, this is A, and we want to go to B. So then, Austin, are you with us? Okay, so then the interval size is going to be B minus A over N. N is the number of interval, B is the end point, A is the starting point, and this is how wide each base is going to be. So in order for us to get from the first point to the second point, we need to add a delta x, right? This is how we get to the next one. And then to get to the next one, you add 2 delta x and 3 delta x and so on, right? So then we can say that to get from the first to the second, it's going to be a plus delta x. So this is the height. And we are going to multiply by the base. Let's see. And we're going to add up all of them. So then we're going to say the sum of. And we are not just adding one square. We have many, infinitely many. So there's an I there, meaning this is the first add up this many intervals, and all the way to the end. So then this is from I equals 1 to n. And n is when limit as n goes to infinity, meaning we're going to have infinitely many rectangles. But most of the time, we don't see it like this. We see it as limit as n goes to infinity of sum of I equals 1 to n of f of, they have really, I guess, many different ways of writing this. I think what they're, anyways. Okay, so it's going to be just the height times delta x. Now, as n goes to infinity, this becomes the definite integral, which is the integral sign from a to b of f of x dx. F of x just means height. Okay, so this is still the same height. Delta x just means base, or this part is the base. And then a to b is from a to b. We always read from the bottom to the top. So this is starting point. And this is the ending point. Okay, we always start from the bottom to the top. Okay, we're going to do two kinds of integral. This is called the definite integral. Definite integral because it has a limit from here to here. So it's definite, like it gives you an actual area. And later on, we're going to do indefinite integral. There's no limit. It's just you're going to give, like what we did before when the antiderivative, you just give them a general solution. Okay, so there are two different ones. This is the definite integral. It has limits. And later on, we're going to do indefinite integral. It has only general solution. Okay, now let's talk about area. So integral means area under the curve. Area under the curve. When we have something like this, area under the curve, if it is above the x-axis, this is all positive area. If it is below the x-axis, this is negative area. When you talk about area, obviously, we're just talking about a quantity, so we usually just keep them as positive. But integral, we're going to look at positive and negative. So anything that's above the x-axis is positive. Anything that is below is negative. Okay, so let's look at this theorem. If f is continuous, so anytime you see a theorem, you always want to ask yourself, what's the condition? If f is continuous on the interval a, b, or if f has a finite number of jump discontinuities. Okay, so if it's continuous or it has a lot of jump discontinuities, then f is integrable on AB. That is the definite integral a to b of f of x dx exists. Okay, what this means is if f of x is continuous on this interval, or on this interval it has a finite number of jump discontinuities, then you can figure out the area underneath this curve.
How do you say that word? F is
Integral.
Integral.
Integrable. Integrable? You don't know? Integrable? Integrable? Okay, for now, we're just going to look at it as the area under the curve. And then next section, I'm going to show you how to actually solve any kind of integral. Okay, so let's look at these definite integrals by interpreting them as the area under the curve. No. No, because then there's no point. Your calculator will solve all this. All right, so let's look at number 1. The integral of square root 1 minus x squared dx from 0 to 1. All right, so remember, this is the f of x, which means the height. This is the base, delta x, right? So we're just finding the area under which curve? The height curve, right? So then whatever that shape is, we are trying to figure out the area between 0 to 1. That is an interesting curve. That is a half circle. From -1 to 1. This is just a special case, so just letting you know that this is a half circle. So from 0 to 1. From 0 to 1 means this region here. And this is a half circle, so the radius is 1. So what is that area? 1 over 4 pi r squared. And then in this case, what is r? 1. So this is pi over 4. All right, let's look at another example. So for now, just think of it as an area under the curve. In the future, I will tell you how to integrate that. Okay, next one. The integral of x minus 1 dx from 0 to 3. All right, so again, this is f of x. We're trying to figure out what is the area under this curve. All right, let's kind of first graph this thing, x minus 1. How does x minus 1 look like?
Straight.
It's just a straight line this way, right? And where's the y-intercept? -1. So this is this graph. We want this from 0 to 3. So this is 1, 2, 3. So we want this. Okay, remember that anything that is above the x-axis is positive, anything that's below is negative. Okay, so basically we have two triangles. One is positive, one is negative, so we got to add them together. Let's figure out the positive area first. How do you find the area of this triangle? You have to know the height, right? How do you know the height of this triangle? Plug it into f of x, right? So if you plug 3 into f of x, you get 2. So then that tells you this is 2 high. How wide is the base? 2. So then this is 2 times 2 divided by 2. So just 2. So this is 2. What about this one? What is the area here? Half, and because it's negative, we had to put minus 1/2. So minus 0.5. So then the area is going to be 2 minus 0.5, which is 1.5. Good?
Would it be 1.5 units squared?
You can, but then, yeah, I think these ones, they just want the number. All right, next one. This one you're going to do on your own. So no calculator, but I will show you how to use your calculators just in case you need it in the future. And let's look at this curve together. This is, the y-intercept is at 5, and it goes up 3 over 1. So at -1, you can just plug it in. -1 is 2, right? Oh, then I did this wrong. -1 is at 2, right? -1 times 3 plus 5 is 2. And then at 2, it is 11. Okay, thank you. So this is a trapezoid. Okay, this is a trapezoid, so we are going to take the trapezoid formula, which is 1/2 times the base, and base is 3, times the height plus height, so 2 plus 11. So this is 39 over 2. All right. Okay, let me show you really quickly how to do this on the calculator. So everyone, please take out your calculator.
Oh,
Lovely. You get to learn how to just choose the thing.
All right, so what you're gonna do is go to the math button and then scroll all the way down to FNINT.
That's nice.
Oh, so you just plug in the formula and then put dx.
Right. And yours should just be an exact integral, unless you're the older version. Then it looks like this. I believe what you do is you type in the equation. Oh, sorry. If yours look exactly like the integral, just type in an integral. If yours is the old version, it looks like this, and then I think you have to type it in like that. And then it should just give you the numbers. 19.5. Good? Okay, so just showing you how to use this on the calculator because for now, all the numbers are really easy, but in the future, they will give you something that's really strange. You have to use the calculator. All right, next. This is the tricky one. We are going to switch between Riemann sum and the integral back into Riemann sum, and then you have to know how to write them all in different ways. Okay, so let's look at this example. We are going to turn this into an integral expression. So from this Riemann sum, what you're doing is you're going to try to figure out which one is the height, which one is the base, and what is the limit. What's the limit of my definite integral? Okay, well, here's what you want to notice. This part, the really complicated part, is always the f of x. Whatever they multiply is always going to be the delta x, the dx. Notice that dx is repeated inside, right? This is basically, if you kind of look at your previous page's notes, that is the a plus delta x. So this part is a. Because there's a starting point, okay, evaluate from here when I is blah blah blah, and then add the next base, and then evaluate, and then evaluate, and then you keep continuing. So that part is a. Okay, so now what we're gonna do is figure out b first. So delta x, we know has to be from the end point minus the beginning point and divided by however many intervals there are. This one is infinitely many intervals, so we're just gonna kind of ignore it and write a definite integral. Okay, this is equal to 2 over n. Right, because we already figured that out. The part they're multiplying at the end, 2 over n, has to be dx. Now, we also figured out that a is 1. We're starting at the number 1. So b minus 1 over n is equal to 2 over n. And now it's a really simple matching game. So b minus 1 is equal to 2. So b has to equal 3. So this is the limit from 1 to 3. The next question is, what is f of x? What is f of x? What do you guys think?
Just natural log x.
Just natural log x. This 1 plus 2I over n is just a plus delta x I, delta xi, because I is going to keep increasing. So it really doesn't matter. So to rewrite this as a definite integral, it is just from 1 to 3 of natural log x dx. Don't forget your dx. So this is plus delta xi if you, I'm not sure what's going on. Okay, so at first, when you look at it, it looks very scary because it has all these symbols to represent something. But as you decipher it, it's not as bad. Okay, let's try one together. Let's look at this question. Change this into a definite integral. First part, try to figure out delta x. What is delta x? Which part is delta x? 5 over n. Okay, and then so that means this is f of x. All right, so delta x is b minus a over n, which is 5 over n. And the next part is try to figure out what a is. What number is a? 2. Can everyone see that, or everyone's just still trying to copy down the question? So 2 is a. All right, so go ahead and solve for b. All right, so b is equal to 7. So then you can see this is pretty much the same as the previous question. 2 to 7 natural log x dx. All right, let's try another one. Okay, what number is delta x? Pi over n. And this part is f of x. What number is a?
0.
Yeah. When there is no number, it's just 0. All right, go ahead and write the definite integral. Okay, so b is equal to what? Pi. So the integral is from 0 to pi of cosine x dx. Again, don't forget your dx. Okay, now we are going to turn from definite integral into Riemann sum. All right, so just go backwards, right? Okay, so first we gotta write delta x. Delta x again is from b minus a over n. What number is b? 8, and then a is 3. So a minus 3 over n, this is 5 over n. All right, once we figure that out, everything else is pretty much just a skeleton. You just have to copy it exactly. So it's limit as n goes to infinity of the sum from I equals 1 to n. Okay, that part is given, it's fixed, it is just the way it is, and you just write it like that. The next part is you gotta take that function and then rewrite something. The function is x squared, so what we're gonna do is we are going to write it from a plus delta x. Okay, so a in this case is 3. Delta x is 5 over n. But delta x is gonna keep changing as we move along the rectangles. So we're going to put an I there to tell us that we're gonna move it. And then we're gonna multiply by delta x, which is 5 over n. I'm sorry, I forgot, square it. Because that is the function, x squared. And then you're done. Okay, so again, what you wanna do is find delta x first, b minus a over n. And then when you write the Riemann sum, the first part is given, that is just the way it should look. And then a plus delta x I, and then whatever that function is, and then times delta x. Okay, let's try one. Number 1. What is delta x? Oh, you guys are copying down the question first. Okay, what number is delta x? So it's b minus a over n. What is that? Everybody's just working. Anyone?
No, 3 minus 0.
3 minus 0 over n, so 3 over n. All right, so limit as n goes to infinity of sum of I equals 1 to n. And then what goes inside the sum? E to the 3i over n.
Times 3.
Times 3 over n, yeah.
Oh, 3 over n is multiplied or?
It's multiplied.
It's not e to the, it's not e to the 3 over n.
It is. Because you're changing the x part. Does that help? Is that exponent? Okay, let's try another one. Okay, delta x is 9 minus 2 over n, so that is 7 over n. So this is the limit as n goes to infinity of the sum from I equals 1 to n of square root of 2 plus 7i over n times 7 over n. Good?